Hello everyone, welcome to the channel. So in today's video we will talk about the stack data structure, and in our series of this data structure and algorithm we move forwards towards the data structure. So first we will learn about stack, then we will move forward towards queue, and then linked list, then tree. So in this way this series will be going forward in upcoming weeks. So first we will learn about the stack, what exactly is stack, how many operations are there in stack, and through different ways how can we perform stack. So we will be looking out stack through the Java. And so let's start. So talking about the stack data structure, so stack is basically a linear data structure, and that accomplishes basically a principle known as the LIFO, last in first out. So LIFO stand for, if basically in a stack like you see on the uh, this picture on the left hand side, you see a stack of books are there. So if I inserted or if I put those books in a specific order, then the first one book that I placed would be removed or would be picked up at last, and the book that I placed last, that would be picked up by first. So this principle is basically known as LIFO, last in first out. Okay, now talking about the stack operations. So so stack has basically three operations, and we perform these three operations. So to insert in a stack, the operation is basically known as stack push operation. So in the push operation, basically we add elements in the array or linked list or whatever DS we are going to use. So we add an element on the top of the stack, you see here. So we are going to add on top of this stack the element, and every time we are going to add n number of element, it is going to be placed at the top of the stack. The next operation that comes in stack is a pop operation. So pop means we remove the element. So whenever we try to remove the element, it will always be removed from the top of the stack. So you can see a stack is there, you cannot remove it from the first, or I would say the item that is placed or touched at the bottom. So you have to remove from the top. Okay, so it removes the top element from the stack. And the third operation that we basically perform or use in stack is known as peek operation. So peek basically returns the top element without removing it. Okay, so these are the three operations basically we use in stack. Okay, and like I've told you, there are multiple number of ways through which we can perform stack operation. We can do with array list, we can do with linked list, and we can do with array itself. And we have a data structure in Java, also a stack data structure present in the Java util package. So we can also use that data structure to implement the stack, but that is the predefined stack class. And push, pop, and peek operation, all operations that we are going to use in stack are already defined in that class that basically resides in the Java util operations. Okay, so let me just give you a overview what we have learned till now, or the key points related to stack. So stack works on the LIFO pattern. First thing, as we can observe, like let me just draw a figure. Okay, so we can see in this picture it's a stack of books. Okay, and in this stack of books we add it from here. We have first added this book. This is the first book that I have placed. Afterward, this is the second book I have placed. Afterwards, this is the third book I have placed. So whenever I try to add anything in stack, it or if I say, if I wanted to store elements in a stack, and let's say assume this is my stack as of now and it is empty. Okay, so this will be pushed or this will be placed from here only. I placed up here, then this. So every time I place anything, it comes on the top of the stack. Okay, so this is the standard stack operation push. Like whenever we insert an element in a stack, then that operation is known as push, and that operation automatically comes on the top of the stack. Okay, and if I remove or delete an element, then the operation is known as pop, and the stack would automatically remove that element from the top itself. Okay, we can also similarly take one more example. Like if we are washing up the plates in the in household, then after washing up those plates, we usually put those plates in this way. I put up a plate, then again I put up a plate, then again I put up a plate, then again. So we can see these are a stack of plates. Okay, so the first one that I put will always be come at last, and the last one that I put will always be come at first or removed at first. So this is the LIFO data structure I'm talking about. So stack is a LIFO data structure, means last in first out. Now talking about the three operations we studied or we have learned are push, pop and p. Now talking about the three these operations, we will see like how we can perform these operations. So first we will see how we can perform this operation using the array. Okay, using a standard way. Now let's switch to the IntelliJ and see the code. Okay, so the first program that we are going to write for stack, in this program we will be writing stack and implementing the stack through the array. Okay, let's create the program. So I'm just first writing the make method, and firstly I'm just going to create a static class stack. Inside this I will be creating an array. I will also be creating one top and size of my array. Now inside this I will be creating a default constructor, and inside this I will be passing the size of the stack and initializing this for my array. Okay, so I will be passing this this way. I will be creating my object, and inside this I will be passing the size of my stack. So my size is 5. Now I will be initializing the capacity. So capacity is equal to this, and also I am initializing the value of top. So initially top is going to be -1. So I have this stack. Okay, so initially my stack is empty, I'm not sure. Okay, -1. So after I do the push operation, I am going to just increment this to 1. Then I'm going to insert it here, whatever value it would be, like 1. Then I'm going to insert it here 2. So in this way I'm going to push elements in my stack. Now I'm going to write the push operation. So for the push operation I'm just going to define a method public static void push. Okay, so in this method I'm just going to insert my elements. Now before writing the push operation, or I would say the push method, we need to do some validations. Okay, so before inserting an element in a stack, we need to first check whether my stack is full or not, because you see, I know my stack is empty as of now, but what would happen if my stack is full? So for that, if we try to insert an element in the stack and the stack is full, then there is a type of condition known as overflow condition. We should just write that condition and just throw a type of exception, or I would say a warning or a message. Okay, and when we initialize a stack, that is why we set the value of top as -1 to check that stack is empty. And if the stack is empty, then only I am going to insert the element. Okay, and then when a new element is pushed in a stack, then the first value of that top automatically gets inserted, not inserted, incremented to top plus plus, that is -1 to 1. Okay, so now for this I'm going to define one more method. Public static boolean is empty. So this method will check whether a stack is empty or not. So if my top is equal to -1, then my, okay, I need to also initialize these variables as static. Okay, then my stack is empty. Okay, and how would I know if my stack is full or not? Then I also need to define a method is full, and this will return if my top is equal to capacity -1. Okay, why -1? Because my capacity is 5 and I'm going to initialize, or insert the element in stack from 0. Okay, so here I'm going to just check if is full, then I'm going to just print a message that says stack overflow. Okay, and I'm just going to exit. Okay, now if the condition is false, then what we will do, we are going to just increment the top and we are going to insert the data. Okay, fine. So our data would be inserted. Now the next operation we are going to see is the pop operation. Okay, and in the pop operation, like I have told you, pop means to remove the element. So for that also there are certain steps and validations are involved to do the pop operation. So for the pop operation, what we are going to do, for pop, first we need to check if my stack, before deleting the element from the stack, we need to check if my stack is empty or not. If we try to delete the element, like if I haven't pushed up any element in the stack, and if we try to delete the element from the empty stack, then a specific underflow condition or stack is empty condition should be provided. Okay, and if the stack is not empty, we first access that element which is pointed by top. My top should be here in this case, so that top should be removed, and once that pop operation is performed, my top operation should be decremented to this one position. Okay, so let's see how we do that. So here I'll first check if my stack is empty. If that is true, I'm just going to print one statement and I'll write stack is empty, and after this I'll just write system.exit. If not, this condition is false, then what I will be doing, I will be just decrementing my top and I will be just returning this. Okay, so what we have done here, we have removed the top. Top is pointed here from the array, and we have also returned the value of the current where top is pointed. Okay, now next operation we are going to see here is peak operation. So in peak operation, what we are going to do, we are just going to display the elements or display the stack. Okay, so for peak operation we just need to return array of top, and also we need to see if my stack is empty or not, because if my stack is empty, then what I'm going to return. Okay, so these are the three operations we usually perform, and now let's just check this. So I'm just going to push some values in stack. And now I'm just going to print these values. Okay, there is a expected at line number 54. Okay, I have missed. Okay. Okay, so it's displaying only 3. Okay. So why it's displaying only 3? Because in the peak operation, what we have written up here, we can see we have only written here to return the array of top, means to return the top position. So it will only return the top position like I have inserted here. It would be like 0, 1 and 2. So in the second index it has returned 3, but when I pop this it will then return 2, then I pop this it will return 1. So now I'm just going to tweak my condition, and I'll just first I will uh, peak, and then I will pop, then again peak, then pop, then it will look up into the entire stack. Now just going to tweak this condition, and here I'll just write while stack is empty. If my stack is not empty, then it goes into this while loop, and it will first peak and then it will pop. Now again I'm just going to run this. Now we can see first it has printed the third, that is on the top of the stack, then it removed the third element, popped, then again while loop is ran to see the condition stack dot is empty, then it peaked, then it checked, okay, 2 is on the top of the stack, then it popped 2, then again it checks the condition, and in this way it you prints the all element that basically exists in the stack. So this is the first data structure through array. This is the stack data structure we have learned through array. Now we are going to learn stack through the linked list. So next we are going to just create a linked list, and we will just push the elements using the stack. Okay, so we'll perform the push, pop and peak operations. Okay, so let me just create a new class, stack using linked list. Okay, and I'm just going to rub this. Okay, now similarly I'm just going to first create a main method, and to do the stack operation using the linked list, first I have to create a class. This class will be known as node. Okay, so inside my node, like usually what exactly we do in linked list. Okay, so in the linked list what we do, so in the linked list we have this, okay, element in the 0th position, and this is the first position, this is at the second position. So here I will be inserting my element, let's suppose 97, and this will be contains the next element's pointer. Okay, so it will contains the next element index. So here I will be writing 1, then again I will be writing any element, let's suppose 81, then 2, next index in my next position, and then I will be inserting 72. Then in my next I will be writing the next index position. So here no next is there, so I will be writing null. Okay, so in this way we are going to perform the linked list. So first we are going to create a node. So let's create a node for the linked list. So here in this, first I'm going to create data, then I'm going to create node next for the next elements index I have to store in my next position. Then I'm just going to create a constructor, and inside this I will be initializing my data, and next initially will be null. Okay, now I'm also next I'm going to I'm going to create the static class stack, and inside stack I'm going to initialize node variable. Okay, and this will be static. I have to do okay. Now I'm going to perform the same operations that we have performed using the array. So first would be the push operation, and similarly we have to perform the initial validation for that. So first we will be checking is empty. So inside this not no param is actually required. So I'm just going to check if my head is empty or if my head is null. Then if my head is null, so in linked list we have a head and we have a next variables we basically use in linked list. We don't use the top like we basically use in the stack, because stack stores in in a type of LIFO structure, but linked list not stored in a type of LIFO. So these are the terms we used in the linked list. We will further in the linked list video we will learn about this, in about the linked list topic, and what and how we do linked list operations. Okay, so we will return null if my we will return empty if my head is null. Now inside the push operation I'm going to check first if is empty. If that is true, then my head is null. Then my new node, okay, I need to initialize node, new node, data. Okay, and if my stack is empty, then head equal to new node. So my new node will automatically becomes the head, so it will goes up here. Okay, and if this condition is not true, then new node dot next equal to head, and head equal to new node. So what exactly we have done here, let's just understand. So let's suppose my linked list is empty as of now. Okay, and first I'm going to check this condition if it is empty. Okay, if this is true, then the data, or I would say the new node that I have created, will automatically becomes the head position. Okay, then this would be 97 null null. But what if this is not true? There is data already inserted. Let's suppose this is the data. Okay, then I'm going to insert you know against this, not here, because I'll still considering this as stack. So I'm not going to insert this after 2. Still this is a stack, so before this I have to insert, or before this. So what I'm going to do, this will be my head. Okay, so my new node, or my new, new node, or my new element will be inserted here, and the already element that is present at the top of that linked list, or I would say top of the stack, would automatically become my next. So new node dot next will be head. Okay, so I will be pointing to this. So let's suppose I have inserted 79, so new node, so in the next I will be writing head, and my head will automatically becomes this new node. So this is the way we going to push in inside a linked list for the stack. Okay, now going towards the pop operation, what we are going to do, public static void pop. Okay, I need to return the end, the latest one. Similarly, we are going to check here, if my linked list is empty, then I'm going to return -1, and after this I'm going to just return the top value. So top would be head dot data. Okay, so top would be the you know head would be automatically at the top of the stack, and the data I have to return through this top. So top I have to return, and I have to remove this element from the linked list. Then my head would automatically become head dot next. Okay, so head dot next, the next element in that linked list would automatically become head, and I'm just going to return this top. So my top will be removed. The next element, or I would say the next node after that head, will automatically becomes the head. Okay, so this is the pop operation. Next we will see the peak operation. So inside this peak, what we are going to do, we are going to just simply check first is empty condition is empty. Okay, I haven't written if. Okay, then I'm going to return -1. Otherwise I'm just going to return the head. Okay, perfect. Now I'm just going to just copy paste this, and just going to write up here. Okay, now okay, it's not this stack. Okay, I have to just write this stack, and okay, and size we don't usually do in linked list. So the difference also comes up here is like array, we have to define a fixed size. Array basically contains a fixed size, but not with not this case is not applicable basically for linked list and for array list. So these two can be of variable size. Okay, so that fixed size complexity didn't usually occur in the linked list and array list. So we mostly implement the stack using the linked list and the array list. Arrays basically comes up a complexity of size. A limitation is there that you have a fixed amount of size, and you only going to insert all those elements, and each time you have to check for that is empty and is full condition, but not the case with the linked list. Okay, now just I'm going to run this, and okay, the similar operations are there. Okay, my stack would never be empty, so this is the case. So what I'm just going to do, I'm just going to push this. Okay, but I haven't printed it. Just okay. Okay, but what did I missed that it is going to in pushing only and not. If a node is invented. Okay, okay, I got it. Okay, so I haven't written the return statement that after inserting we have to return. Now this will run. This will just and let's just change this to 78, 98, and 35. Now just run this and let's see if okay. So it's solved. So it's going to insert or just push these elements. So it's pushed 78, then basically 98, 78. So what it does is it first remove this 35 because it comes on the top of the stack. You see 35 is going to be at the top because inserted at the last, and it will be out first. So 35 is returned peak 35 is at the top, popped, then 98 peak, popped, then 78 peak, and then pop. So in this way we are going to implement stack using the linked list. Now next we are going to see stack using the array list. So I'm just going to remove this and let's create a new file and let's see stack using the array list. Okay, so let's create a class first using array list way. So stack using array list. Similarly, we first will be writing the static void main method. Okay, now like previously we will be first creating a static internal class or inner class, I would say, stack, and inside this we will be creating the variable. So I will be creating this using my array list. Type would be of integer. Okay, so we have created the array list. Now the operation would be there. So first operation would be push operation. Before that I will be writing the is empty check, return stack dot size equal to 0. Okay, now the push operation stack dot add data, because these are the predefined operations. So if my stack size is equal to 0 means it is empty, and if I have to add in a stack, then I have to add in a way like no, so okay, just missed it. So usually what I was doing earlier in the linked list way, I was checking while pushing up if my stack is empty or not. Similarly in the array style way, I have checked if my stack is empty or not, but using the array list I'm not going to check this anymore. Why? The reason is that in the array list it's not of the fixed size like we have previously in the stack using the array way. And the linked list way, what why I was doing that check, because I was checking if I have to insert that specific or particular node. Okay, and if I have to insert, then if already there is an element, so in the next position I have to add up that index, or I have to add null. So for that I'm going to have that empty check. But here there is no case like that of a linked list or a fixed size of an array, so I'm not going to check up here. Similarly in the push operation, I'm just going to now check in the push here. So not in the push, just the opposite, pop operation. So here I'll checking if is empty, then I'll just returns -1, else I'll just returning the top. So stack dot get stack dot size -1, and I'm just going to remove stack dot size minus 1. Okay, remove this element and just going to return the top. Okay, so I have got the top position, then remove the element, and that is at the top of that stack, at the probably size minus 1 means at the bottom. Consider it as a bottom because stack would store it as a in a way like we have seen like a stack of books or a stack of plates. So in this way we are going to remove that element. Now for the peak also, I'm going to first check the is empty check. So I'm just going to return stack.get stack.size minus 1. Okay, and coming up here, now I'm just going to copy paste the same elements I've used here. Okay, and just remove this references. Okay, now just going to run this. Okay, I'll just run a different I'll just try adding some different elements to make it better. And yeah, so 5 is the last one we have inserted. First one would be removed, 78 is the next, 56 is the next. So in this way we perform or we write stack using the array list way. Next we are going to see the final way, or I would say the way where we see the stack data structure. So I'll just I'll just use those data structure up here and just comment it out for, and I'll just write stack of integer type and stack. So stack is a predefined class. Okay, it's okay, I got it. I need to just stack java util I'm talking about. Okay, I have to write this because I have already defined a class, so it's by default picking up that. Okay, now it will be picking the java.util. So stack is a predefined class introduced in java 1, and it is a like LIFO based data structure. So we are going to use this class to push and pop. Now using this I'm going to just push. Let's just push these items, stack dot push, and similarly I'm just going to use the internal methods, or I would say the predefined methods, and let's just print this 69178. So I have used here the stack data structure defined by java itself in java.util package, and I have used its own operations already defined. Push operation, we can see internally it's going to add call the add element, and it's going to just add those elements inside the stack. Similarly we have a pop operation and we have a peek operation. So these are the four operations we usually use in the stack: push, pop, and peep. And through these four ways, stack, data structure, array list, and linked list, we can perform the stack operations. So that's it for today, guys. If you have any query or question, do comment and I will be happy to help.